All right, this part of the weather basics is about fronts. And before we talk about the particular types, what I want to say about a front is that basically when I use the word front, when I'm talking about weather, it just means a boundary line, okay? A front is a boundary. And in weather, a front is a boundary between different air masses. So between two areas of air that have different characteristics. Okay. Weather's not the only place where we use the word front to refer to a boundary. It can be used in military terms. A front in military terms is typically the front lines, the boundary between two armies, that kind of thing. Okay. But in weather, it's going to refer to the boundary line between two different masses of air. All right, so let's talk about cold fronts. A cold front, first of all, is depicted with a blue line, if your map is in color, okay, with little triangular spikes on it, okay? So a cold front's a boundary line between two masses of air, and it is called a cold front because it is the colder air that is moving in and shoving the warmer air out of the way. So if it's the cold air that's on the move, then it's a cold front. If it's the warmer air that's moving in, then it's going to be called a warm front. It's pretty basic. Okay? Now, while the front is moving through a location, when we're talking about a cold front, there are often storms because the warm, less dense air is being forced up. I'll show you kind of a picture of what I mean in just a minute. But after the front passes, after the cold front passes, typically a location experiences cooler temperatures and often drier, clear weather. And the drier, clear weather has to do with the fact that, remember, colder air typically is more dense, and that's going to be sinking air and higher pressure and nice, clear weather. Because remember, high pressure tends to go with clear skies because you don't have a lot of cloud formation. All right, but a cold front just means it's a boundary where the cold air is on the move. And by the way, the little spikes on the line point in the direction of the boundary movement. So for instance, if this was our cold front, we have colder air back here, warmer air over here, and it's the colder air on this side that is moving in. Okay? Here's kind of what it looks like. You've got colder air moving in, and really because the cold air is less dense, it's going to kind of roll in along the ground and act as a giant bulldozer. It's going to shove all of this warm, less dense air up. And remember, warm, less dense air being shoved up can be what it takes to form clouds, thunderstorms, and things like that. And when you get a really strong cold front coming in, that is what you often get, is you often get a line of thunderstorms that come in as the cold front passes. Okay, and then once it's passed through, you typically have nice clear weather. All right, so a cold front, you've got cold air on the move. Well, I bet you can guess what a warm front does. A warm front, you've got the warmer air mass doing the moving, and it is moving in and overtaking colder air. Now, if it is a warm front, the mixing of the air is a little bit more gradual and a little bit less eventful because it's the cold air that's already sitting there and the warm air is moving in, and it mixes a little more gradually. It doesn't have that kind of bulldozer effect that this cold front does coming in. Okay? All right, so again, a warm front is just simply a boundary line, and in this case, it's the warm air that's doing the moving. Okay, again, they're going to use red because they think, red with warm and blue with cold. A warm front is typically on a colored map is going to be red with little humps. And the humps are kind of like the spikes. They point in the direction of movement. So this warm front means that this air is moving this direction. Okay? We also have something called a stationary front. A stationary front is just simply a boundary between two air masses, and neither one of the air masses is moving. They are both stationary. Okay? If I look at this for my frontal boundary, I have a little piece of a cold front line, a little piece of a warm front line, a little piece of a cold front, a little piece of a warm front. And what that means, what that tells me is that the warmer air is up here, and if it were to start moving, it would be moving this direction. That's why the spikes are pointing this way. The warmer air is down here, and if it were to start moving and become a warm front, it would be moving this direction. Okay? So I've got the cooler air up here, ready to go south. I've got the warmer air down here, ready to go north. And depending on which one starts moving, sometimes a stationary front will stay for a while and then it becomes a warm front if the warm air starts to move somewhere. Or sometimes it'll stay for a while, a stationary front, and then it'll become a cold front because it's the cold air that starts moving. Okay? A stationary front, again, is just a boundary line. It's just called a stationary front because nothing's moving at that point. Okay? All right, so it's a boundary between two air masses, but if neither one are moving, then it's a stationary front. Okay? All right, let me show you. All right, so here's our weather map. We've got a boundary line here. This is a stationary front. So this is a boundary where we've got cooler air up here, warmer air down here. I know that the cooler air is up here because if it were to move, it would go south in the direction that the spikes are pointing. I know I've got warmer air down here because if it was to start to move, it would go in the direction that the humps are pointing and it would go north. Okay? And then this part is a cold front because this air in here is colder and it is on the move. Then we have another stationary front right here. Okay, so we've got warmer air here, cooler air here. If the cooler air starts to move, it would go this way. If the warmer air starts to move, it would go this way. And you're like, well, wait a minute. How can I have like a cold front and then a stationary front and whatever? It's a comparison. I know that this air is colder than this air and that this air is moving, therefore it's a cold front. I know that this air in here is warmer than this air over here because of the way that things would happen if this frontal boundary started to move. Okay, so it's just comparison. It's not an absolute. And then I have a cold front up here so that, this air was colder than this air, but obviously this air is colder than this air and this air is moving in. So they're just boundary lines between air masses of different characteristics. And then we have a massive stationary front sitting here, going through Tennessee, border of Arkansas and Missouri, down through Oklahoma, across part of Texas. Okay? So right now it's a stationary front, but if part of it starts to move, then it becomes a warm or a cold front. So it's only stationary, literally, while it's not moving. Okay? Got some more cold fronts over here. Okay? So for instance, this cold front in here, this air is moving down, moving south. Once this colder air moves in, then the temperature of an area's temperature is going to drop. So for instance, once this cold air moves past this weather station, the temperatures that weather station are going to be recording are going to fall because colder air has moved in, that kind of thing. Okay? All right, so that's your brief little tutorial about your frontal types. There's 3 basic types. Remember, your cold front, warm front, and stationary front. There's actually another one. It's called an occluded front, but it's not in this slideshow. I do think that maybe it's mentioned in your book. I don't remember.